In this video, I'd like to go over a couple more examples where we are matching an equation for a trig function to its graph. And I thought it might be helpful to just remind you that we do have these parent graphs, which we've been working with. The examples in this video are going to focus on tangent and cotangent graphs. So just to point out a couple of characteristics that we should be looking for. Both of these graphs have a period of pi. The cotangent is shifted to the right, pi over 2, but they both have a period of pi. They both have this little inflection point along the midline, right, which is the x-axis right now, where they change from curving in a downward direction to an upward direction, or a downward direction, or an upward direction to a downward direction. So that's an important point that we're going to keep an eye on as we look at these graphs. And then remember, if we multiply by a bigger number, it'll stretch this thing out, and if we multiply by a fraction that's less than 1, it'll squish it down. But that's the basic structure. So we'll focus on these two for this video. And our goal is just to look at an equation and see if we can pick out the graph out of a choice of 4 graphs. Let's jump into the examples and we'll take a look. So in this problem, we're actually going to have a cotangent function, which we know is very similar to a tangent function, but it heads in the opposite direction. So what we've been doing is we've been identifying some important characteristics. First of all, the a value is that multiplier out in front, which is a 3. That stretches the graph out some. The period we get by dividing pi by 1/3. We get that 1/3 from this k value here. So pi divided by 1/3 is 3 pi. The vertical shift for this problem is down 2 minus 2. That's this guy right here. And then the phase shift, which is the left or right movement, is 5 pi, negative 5 pi over 3, divided by 1/3. And we get that from here. It's negative c over k. Negative 5 pi over 3 divided by 1/3 is just negative 5 pi. So this cotangent graph has been shifted to the left. It's been shifted down. It's been stretched out, right? The period is longer. And it's been stretched up and down with that multiplier of 3. And our job is to kind of figure out which one of these graphs we should choose for this particular choice. So right away, I can see that the period for letter C is way too small. It is nowhere near 3 pi. So I'm going to throw that one out. The next thing I want to see if I can identify is this vertical shift here. That graph should have been shifted down 2 units. That means that inflection point is going to be down lower, right around this line. And of the 3 graphs that I see here, only letter A appears to be shifted, right? That looks like it's probably that inflection point that we talk about, where that cotangent function changes the way it's curving. It's clearly not accurate on this graph because we missed that by quite a bit, right? It's not here. It's up in here somewhere. And I would say this one's probably up in here somewhere. So I'm going to rule out letter D too. So I'm pretty sure that A is the right graph. Now, just to be sure, I should also check a few other things, like I should check the period of this thing. So it looks like there's a asymptote dropping somewhere down in between these two, and it looks like there's another one dropping in somewhere between these two. And if you count every 2 squares as pi, I go 1, 2, that's a pi, 3, 4, that's a pi, 5, 6, that's a pi. And that looks like about 3 pi. So I do have the right period. The phase shift of 5 pi, negative 5 pi, is a little harder to figure out because that thing shifts so far off the graph this way that the cycle comes back. But I definitely think we've done enough to assure ourselves that letter A is the correct choice for this graph. Let's take a look at one other example on the next slide. So here we have a tangent function. And as we did on all the other problems, made a mistake there. We're going to list our values, right? So we've got that multiplier of 1/2. What that's going to do is compress our graph down a little bit around that midline. Our period is going to be pi divided by by 1 over 2, which is 2 pi. When you divide by 1/2, you get 2 pi. Our vertical shift is again -2, because that -2 right here. And then our phase shift for this one is going to be negative pi over 3 divided by 1/2. That's actually a negative pi over 6. So this graph has been shifted slightly to the left. Now the tangent function, remember, it had that characteristic where that inflection point was right at the origin. And what we're saying is we're going to move that thing over and down. So that'll be something that we'll look for. Okay, let's start throwing some of these graphs out. Our midline is moved down to -2. I think that clearly rules out letter A, because that line looks like it's... Our period is 2 pi, and if you take a look at letter B here, there are several cycles in here between 0 and 2 pi, so I'm going to rule out letter B because it failed the period. So that leaves me with letter D and letter C. And I'm thinking that letter D looks like the right candidate, because remember, we moved this thing down 2 units. That little midline, that place where we hit that inflection point, should move down to -2, and I see right here that it has. It looks like this one is either right at the x-axis or maybe a little above. That one does not fit what we're looking for, so I'm going to rule that one out. So letter D is going to be my choice. I do want to just double check and make sure the period's 2 pi though. So if I draw this asymptote in right in here somewhere, and draw this one in right here, remember every 2 squares is a pi, so 1, 2, 3, 4, yes, we do get a 2 pi in there. So it does fit the period as well. So for this graph, I'm going to choose graph D. Okay, I had an example with a cotangent and an example with a tangent, just showing you a couple more examples of how we determine which graph to choose. And at some point when it's multiple choice, you get as close as you can, and then you just kind of take that leap of faith and make the choice. Hopefully this helped, and we'll see you soon. Take care.